Welcome, kids, to our video on relations and functions. We're going to be looking at a lot of review and some vocabulary that you have already learned, I know, but I will try to give you a few new things in the context of what we're learning so that you feel like this time is not wasted. So let's jump right in with some vocabulary. Okay, vocabulary. So we're starting with the vocabulary of relations. We're going to start with the word relation. What is a relation? Well, a relation is a set of ordered pairs. That relation may or may not have a relationship. There may or may not be a rule for how to find y given an x value, but a relation is just a plain old set of ordered pairs. And that relation has a domain and a range, which are the set of all the x values of a relation and the set of all the y values of a relation. So domain is all the x values, range is all the y values. When you list a domain or a range, you're going to put it into curly braces, so a domain or a range. You're going to put it into curly braces. You're going to list the numbers from least to greatest, separated by commas, with no duplicates. So even if a number appears more than once, you're not going to list it more than once. Okay, good. Moving on to function. What is a function? A function is a relation where each x value has one and only one y value. And in a second, I'm going to make an additional slide and talk about why that's what makes a function. I don't think we're going to have as much trouble understanding that as you think you might. And finally, we'll get to that in a second. Finally, the vertical line test. The vertical line test is, it's a test of functionality that checks for x values that are used more than once. And we'll see it in action in a moment. But let's talk for a second about why a function is that definition, why that's the definition of a function. Okay, so here's an example of a graph where time is on the x-axis. And we talked about in class that time, if it's a factor in what you're graphing, is always going to be on the x-axis. So let's pretend this is the height of a projectile. So let's say that this is a football. So we're kicking the football, and it's coming back down. Okay, so we get this nice, happy parabolic curve. Now, at any given point in time, there is only one location for the height of that ball, right here. That's the only possible height for that ball at that time. There is absolutely no way that that ball is going to be in two different locations at the same time. Agreed? That's scientifically impossible. I'm sure some of you are going to come in with all kinds of interesting ideas about some rift in the space-time continuum. But no, you know darn well that you can't have that ball in two different locations at the same time. Well, isn't that the definition of a function? We can't repeat that x value. Okay? That x value can't be repeated. The x value can't be repeated. So that kind of, if you think about it, makes sense because that's what a function is. Your x values can't be repeated. And if you think of time being that factor on the x-axis, this is a great example of why that became the definition of a function. Because in most of the functions we look at, time is the x-axis. Time is what we like to look at because we like to see it pass from left to right continuously. Okay, so that hopefully gives you a little bit more insight into why that's the definition of a function. Excellent. Well, let's move on. Okay, so ways to display a relation. So you see here we've got four basic ways to display a relation. A list of ordered pairs, and there's my list of ordered pairs that makes up my relation. A graph, a table, and a mapping. And actually each one has their own use. A list of ordered pairs would be what you would be given most of the time when I would say, tell me more about this relation. A graph would be a great visual. So the graph for this one, you would just actually graph the ordered pairs on there. I'm not going to have us do that here. The table for this, you would have either x, had the wrong tool selected. You would either have x and y in a table formatted like so, or you could have x and y with a table formatted like so. Either way, that would be what the table would look like. But a mapping, that might be new, okay? If there's any chance of anything in this being new, a mapping is probably it. And a mapping works like this. You have an oval and another oval. And in the first oval, you list your x values. So in this case, our x values are 0, 1, -1, and 2. But we're going to put them in order. -1, 0, 1, and 2. All right, my y values, -1, -3, -1, 1, 2, and 4. -3, -1, 1, 2, and 4. -3, -1, 1, 2, and 4. So this is the beginning of a mapping. We make the two ovals. X is in the left oval, Y is in the right oval. And then you connect the ordered pairs with little arrows. So the -1 goes to the 4 because they're in the ordered pair together. The 0 goes to the 2 and the -3. 2 and -3. The 1 goes to the -1. And the 2 goes to the 1. Okay, so let's make sure we got that right. -1, 4, 0, -3, 0, 2, 1, -1, 2, 1. Okay, so that's our mapping. So again, as we said, each one has its own value. Okay, each one has its own value. And it looks like I probably am going to have to actually quickly sketch the graph. Let me do that real quick. Okay, there we go. There we go. We got our graph now. We got our graph, our table, our mapping. And you see in the table, you would just fill it in. Now, a table is basically like a list of ordered pairs, just a little bit more organized. So I guess that kind of has a use. A graph, of course, we said is a visual. A mapping is another visual. But two of them are great for checking, is this a function? Okay, so is this a function? And if you're already screaming no at the computer screen or whatever it is you're watching your video on, you're right. So let's look at why it's not a function. This is not a function. If we use our vertical line test, we can see quite plainly that right here on the y-axis, if I draw a vertical line, I will pass through 2 points, 1, 2, which means they share an x value. They have the same x value of 0. And you can see that up here in our relation, 0 and another 0. So, of course, a graph, great for checking whether or not a relation is a function. But a mapping is good for this as well. And the place that you want to look on the mapping is you want to look right in here. If you've got any one of these numbers that are x values, where you got 2 arrows coming off of it, ding, 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 0, that's not a function. So a mapping actually has a use too, kind of, sort of. Not a very good one. You know, it's basically the same thing a graph does, but it is something you have to be familiar with. Awesome. Okay, so let's try a couple problems real quick, then look at some parent functions. We'll talk about that in a second, and then we'll be done with. Okay, try these two out for me. Identify the domain and the range of each relation. Represent the relation with a mapping, because that's the thing that's new for us. And is that relation a function? So pause your video, try it out, and then start it up again so you can see it. But I'm going to jump right in here. So, domain. So we're going to express our domain here. X values. So -2 is the smallest, then 0, then 4, then 5. Range. 0.5, 0.5 or 5/10 looks the smallest. 2 and 5/10 is listed twice. Only list it once. Do not list it twice in your range. Oop, that's not a 2. Hold on. Try that again. 6.5. Okay, so there's your domain and your range. A mapping, okay? -2, 0, 4, and 5. Over here I have 0.5, 2.5, 6.5. -2 connects to 0.5, 0 to 2.5, 4 to 6.5, and 5 also to 2.5. So the question is this a function? Yes, it is. Because if you look at this stage here, none of these have 2 arrows coming off of them. It does not matter that these two have 2 arrows, that this value has 2 arrows going to it. That doesn't matter. We don't care about that part. That's okay. But when we look at the x's, that's what we have to look at for domain and range. Good, let's do the other one. Domain, 6, 4, 6, and 5. So 4, 5, and 6. And I'm already sensing, I don't think this one's a function. Range, 5, 3, 4, and 8. So 3, 4, 5, 8. Again, numerical order just because it's customary. Mapping. And look, if I list my domain and range, I can go ahead and use them to write my mapping out because they're already listed there. It makes it a little faster. 4 goes to 3. 5 goes to 8. 6 goes to 5, and 6 goes to 4. And there it is, folks, not a function. No, it is not a function because of this right here. 2 arrows coming off of the 6. Easy peasy. All right, we're going to look at a couple of parent functions. So let's go ahead to the next slide. Okay, guys, a couple of common parent functions. Now, before you furiously copy everything, I do want you to be familiar with the name of the function. I do want you to be familiar with the graph. And then I'm going to talk a little bit about how they express domain and range here. All right, so let's talk about the first one, the constant function. So a constant function is one where y just equals some value that's a real number. C is a real number. That's the restriction on it. So you get a flat horizontal line. It's called a constant function. So the domain of that is all of the real numbers. All of them. We wouldn't give a specific list of numbers because we've got this continuous line here. And that's something we're going to look at in class with some examples so we can do a little bit more focus together, because it's kind of hard to do something that's that new on your own. But the domain here is all the real numbers. So you might actually write, instead of this right here, which means from negative to positive infinity, you might actually write all real numbers. Okay, and we'll come back to that because we're going to see that again in just a second down below here. And the range is just the value c. It doesn't matter what x is, y is always the same. So a constant function is as a horizontal line. A linear function, this is one where you have y equals and then something having to do with x. So it could be y equals x, like this one. It could be y equals x plus 2. It could be y equals negative 4x minus 7. These numbers in here, all these numbers that I've drawn, they amount to something called transformations of the original parent function. And you might remember transformations from pre-algebra. That was your slide, flip, and turn, or translate, reflect, rotate. Okay, so transformations where you actually did something to that function. And so a linear function, one that's linear like this, has the domain and range, where the domain and range both are all the real numbers. There's no restriction on the domain and the range for a linear function. One restriction you do have, though, is that the value of m in this, which should also look familiar from last year, and it's okay if it doesn't, you know I'm going to teach it, is that m can't be 0 in a linear function. Awesome, let's move on to two more parent functions real quick. Okay, two more parent functions. We're not going to spend a ton of time here because these are really ones that I want you to be able to recognize for a couple of activities in class, but they are not ones that technically will be tested on something like the SOL. So the absolute value function, notice the big V for value, and then the quadratic function, notice the big U shape, like the U in quadratic. It's a fun way to help you remember which one is which. Sometimes we exaggerate the way we write it, so we'll write like absolute value like this to help remember, or quadratic to remember like this. All right, and what we're saying here is we've got a couple of different types of functions that, again, can be transformed. You can transform the absolute value function. You can transform the quadratic function. You can see, again, the domains are listed there and the ranges. And this time you've got, again, your all real numbers. Ooh, please excuse that little editing flub there. We've got our all real numbers for the domain of both of them. You can see that on both. But their range, you'll notice, doesn't go into the negatives for these two functions. So another way to express the range would be to say y, because y is for the range, is greater than or equal to 0. And you can say that for both of these in this case. Okay, so just gives you a couple more examples. You might see some examples of this when we do some activities in class, trying to identify a function rule from a set of values. It's possible that these absolute value, quadratic, that constant, it's possible they could pop up on you. So it's good to have them in your notes. So I hope you guys enjoy your fun conference day off. I will enjoy sitting and telling your parents all kinds of awesome things about how great you are. I look forward to seeing you guys when you return to school. Hope you'll be refreshed. And I guess I'll see you in class.